Let's look at some more exciting solutions. Focus here on atmospheric carbon extraction. We have already seen a couple of times that the trajectories we are on in terms of emissions per year and the technologies that are coming on board for energy, transportation, and agriculture and so on are not looking promising in terms of keeping us within the 2 degrees C target, let alone 1.5. So it's pretty clear that we will need some way of capturing carbon and sequestering it, and of course there are a bunch of natural solutions we looked at as well. So we'll run through those again more specifically in this context and repeat a couple of points from for example soil carbon sequestration and so on. So we'll look at the scope, available technologies, and the challenges that go with those. Reminding ourselves again, this is a couple of years old already, or 1 year old. 2020 emissions will not become clear till next year. Nonetheless, going back to the Industrial Revolution and looking at how emissions from different countries and continents have evolved, you can see that more recently, since about 1990, China has begun to dominate, and US is somewhat lower in its footprint, I would say, but mostly because of switching to a lower emission natural gas. India is beginning to grow, so excluding India and China, Asia is up here. The international transportation, Oceania is Australia and the continents and the islands, and so on. So the projections we have looked at say that this is just going to continue for a while. So we need to figure out to meet the 1.5 and 2 degrees C targets with a certain probability, because it's not a guaranteed thing. It depends on evolution of technologies and population and other things. We need to have a sense of how much CO2 needs to be captured from the air in addition to mitigations to reduce greenhouse gases, and what it will cost, and to make sure that it will in fact be possible. Okay, so here is a figure of a little bit older. So 2010 was where we were when this figure was made, I think. So you can see that we were supposed to have started going down these paths for either the medium chance of hitting 1.5 or likely hitting 2 degrees centigrade by a certain time. This is here 2050. So basically, to hit 1.5 C by 2100, we pretty much have to have be drawing down carbon from the atmosphere by these amounts. So clearly we are on a business as usual trajectory right now, increasing at 4 ppm per year or so. Anyways, these depend on whether we can ramp up things, for example, reach 50% by 2032, or in this case higher target of 2 degrees C, reach 50% by 2038, and this one has to reach 0 by 2050, and this one 0 by 2065. So you have to go net negative at some point. Okay, we'll see what that means. There is a definition of a gross net negative and a net gross negative, and net negative based on how CO2 is drawn down. Okay, so what do we have in terms of options to get there? Obviously, we've looked at natural solutions like afforestation when we talked about enhancing carbon sinks in the soil. We also talked about some of the problems there, which we will touch upon again in this chapter. Hybrid solutions like BECCS, bioenergy with carbon capture and sequestration, or accelerated weathering, where you have natural process of weathering which takes down CO2 from the atmosphere, dissolves into water, makes carbonic acid, dissolves rocks slowly on geologic timescales, and washes the carbon products into the ocean where they can be sequestered or on land. And if there is a way to accelerate it, how much potential there is to draw down CO2 that way. Engineered solutions like direct air capture and other methods of taking out carbon and sequestering it somewhere. Where do we sequester it? How stable will it be? Will it leak again? Etc. I have to be worried about as well. So where to sequester and how to pay for it, that's not easy either. If you just go on the internet, for example, very nice site called Carbon Brief puts out incredibly good information, just like the Clean Air, Climate and Clean Air Coalition that we talked about before. It lists 10 options for negative emission technologies. So negative emission here means emitting some carbon but withdrawing so much that we are net negative, as we just saw in that other slide before. Okay, so we will look at direct air capture in this chapter. Cloud treatment to increase alkalinity we will not talk so much about. Enhanced weathering we'll touch upon. Enhanced ocean productivity, there are sites where things like iron fertilization can be done, we will touch on that. Blue carbon habitat restoration we will not look at in this chapter, but this is gaining traction because it turns out the subaquatic vegetations and brackish water species like mangroves and also other salt marshes, wetlands, coral reefs, etc. have a huge potential for sequestering carbon, and some of them can be 10 times the forestation on land. So obviously important, and they can also serve as natural defenses against coastal erosion, habitat and biodiversity protection, against cyclones and storms, etc. And they're nice filters for contaminants, nutrients, etc. coming from land use like agriculture, urban runoff, transportation, etc. We will look at afforestation and reforestation again. We had looked at it a little bit in our soil carbon chapter 16. Here comes my favorite chopper. Every time I want to record podcasts, it shows up. Bioenergy with carbon capture and storage. We will look at that. Building with biomass. We will not look at this so much, but what we will do is to see how captured carbon can be put into cement and make other products. Biochar we will look at a little bit, and soil carbon we already looked at, and we will touch on it again in this chapter. Okay, so that's kind of the scope of this chapter, and obviously it's always exciting to talk about solutions, because most of the climate talk tends to be about how many things are going wrong, and we have already talked about how this is causing climate anxiety among many people. Especially for children, we have to watch out to make sure that they don't get scared that the world is coming to an end by the time they grow up. So they have to be given a pathway to steer their elephant and give it a target, and then give them enough information on what solutions are possible.